Over 10,000 years ago, a howl was lost to time. But today it returns. Meet Remus and Romulus, the first two direwolves since the Pleistocene era. At just 15 days old, the pups take their first wobbly steps before a much-needed nap time. At 1 month, the pups enter a pivotal stage of development, the transitional phase. Here, they begin to growl, chew, and take the first steps into the world beyond the den. But growing up is no small task, and these little ones have certainly earned their rest. Three months in, the pups begin socialization, a key phase in their development. Weaning starts gradually, while play sharpens their instincts and strengthens their bonds. And with a mouthful of growing teeth, chewing is serious business. Antlers and sticks help keep their fangs fit and strengthen their bones. At 5 months, a new instinct awakens. The pups begin to sense structure, challenge one another, and learn the rules of the pack. This stage is marked by rapid growth and an emerging awareness of social hierarchy. Tussles, tackles, and toothy grins. Roughhousing may look like play, but it's serious practice for life in the pack. But wait, there's more. Meet Khaleesi, the first female direwolf brought back from extinction. She may be small now, but she's destined to stand as an equal among her brothers, a fierce force in the making. Their journey is only beginning.
One of the challenges when we started working on the direwolf was that we knew of only 2 direwolf specimens in the world that contained some usable DNA. One of our direwolf samples was a single tooth, and then another was a 72,000-year-old skull. So we were able to use these specimens and isolate this ancient DNA out of them.
For the direwolf, there was a massive study that did many samples across multiple institutions, and Colossal took 2 of those samples and was able to generate whole genome sequences from each. And so this is incredible for any species, let alone species that have been extinct. So what you can do is you can map that to its closest living relative. So at Colossal, we're using the gray wolf, and we've been able to generate such a high quality genome that we can map back to create our own direwolf reference genome.
When we edit different lines of genetically diverse gray wolves, we'll create a set of genetically diverse direwolves with similar edits, but the basis of their diversity already existed within the gray wolf.
Gray wolves are on the endangered species list, and that means you can't just go in and collect the samples that we want.
Typically, people have to take a ear punch or a skin biopsy, and sometimes it's a very invasive process for the animal. We've developed a technology where you can take a simple blood draw, isolate these specific cells in the blood, and then clone from it.
We're changing the genome of this living animal partially into the genome of the extinct animal for those genes that matter, for the traits and characteristics that we want to see in that animal.
Discovering which parts of the genome make an animal look and act like that animal is one of the hardest problems in biology. It is unsolved and something that we have to solve if we want to know which parts of the genome we want to edit to make a gray wolf more like a dire wolf.
To analyze our genomes, to compare direwolves with gray wolf genomes, we use our tools on a platform built by FormBio. It's a bioinformatics company that spun out of Colossal. They built this whole suite of analysis tools and algorithms that allow us to find the differences between the direwolf genome and the gray wolf genome and filter out these differences that we actually want to edit. And so we aligned our direwolf reads to the gray wolf genome. That allowed us to know exactly where the gray wolf differed from the direwolf. One of the most exciting differences that we found in the direwolf genome is that there is a change in the L-Coral gene. And L-Coral is a key regulator of animal size.
Next, we have to use gene editing technologies. We have cells growing in a dish in a lab that belong to a gray wolf. And so these have gray wolf genomes. Now we've decided which part of that genome we want to change. So one at a time, we take our gene editing tools and we go into that cell and we cut out the bit of DNA that looks like a gray wolf and paste in its place the DNA that looks like a dire wolf.
Each time you edit a gene in a cell, you put a lot of stress on that cell because you have to get your gene editing tools in these cells and then these changes are made. So what we do instead is we try to make dozens or hundreds of changes at once. It's called multiplex gene editing.
So now we have cells growing in a dish in a lab that have DNA that makes them a little bit more dire wolf-like than gray wolf-like. We have to transform these living cells into actual pups. And for that, we use a process called cloning, or somatic cell nuclear transfer. This is the same process that most famously brought us Dolly the sheep.
You take an egg, an oocyte, from a wolf or a dog, you take out its own DNA and you stick that direwolf cell in it.
That cell becomes an embryo that's a direwolf. It's no longer a domestic dog, which sounds totally science fiction. And with the help of a vet team, we then are able to surgically put this embryo back inside to the surrogate dog.
We have to find an appropriate dog that can carry our direwolf.
Everyone is thinking very critically about each step so that when that pup is finally born, we know there aren't any issues.
The safety of all of our surrogates for any of our species is the highest priority. We have an overemphasis on our animal husbandry team to secure their safety, as well as are pursuing on the science side our own exogenous development team so that one day we won't have to use surrogates.
The most exciting part is when the vet team comes in, they do their ultrasound and they say, yeah, congrats, you're gonna be a puppy mom, or you're gonna have a cub on the ground in a couple weeks. After the pups are delivered, there's a care team in place. They're there to make sure that our direwolf pups are happy and healthy and that mom has gone through delivery without any problems. And then we have another team that will ensure that our pups have the right dynamics. They have the right social structures.
We're working actively right now with partners today to make sure that there are solutions and places for these animals to go in the future. And it's really important to say that all of this is done in this massive network.
It's critical to work with private landowners, local governments, indigenous people groups, and the public at large to do that in a way that's safe and publicly accepted, but also it's good for the ecosystem and the animals themselves.
What we're doing is having all of this collaboration in place well before we have these animals. And this is absolutely critical to making this work successful.
What we're doing at Colossal has never been done before.
I hope everyone around the world is leveraging the technologies that we develop here, and I hope that biodiversity loss and extinction is just a thing of the past.
The idea of being able to have direwolves again is tremendously, personally exciting, and I think it's going to be exciting to a lot of people.
The first time I see a direwolf, oh my God.
Direwolf's a big fluffy dog that I probably wouldn't pet.